Yes, sir.
Sir.
Yes, sir. Yes, sir.
Yeah. 1 minute. Okay. Okay. Am I audible to everyone?
Yes.
Yes,
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 sir,
sir.
definitely.
Yeah. So today we will do this week 7 solve with us session. So I have 5 questions. We will try to solve all of them. Okay. So before starting this, so let me revise some things for you. Okay. Yeah. Is my slide visible to everyone?
Yes,
Yes.
sir. It is visible.
Yes, sir. Yes,
sir.
sir.
Okay. So we like, I think you all have gone through the video lectures, so you know that A and B is a sequence of real numbers, and n belongs to natural numbers. So in natural numbers, could anyone tell where the natural numbers are starting from?
0,
As far
sir.
as the sequence. But here, I think you have watched in the lectures. It starts from 1,
starting
right?
from 1.
From 1 to infinity.
Yeah,
Positive
1.
infinity.
Yeah. So we say this sequence is said to have a limit A if n comes closer and closer to A. That means as you increase the value of n, that means as you are approaching to infinity, or as you are increasing the value of n, if you're moving closer to a number, let's say some number A, okay? So n is said to have limit A if the numbers n come closer and closer to A as the value of n increases. Is this point clear to everyone?
Yes.
Yes,
When
yes,
n,
sir.
very good. When n tends to infinity, if n tends to A, we say that n has limit A. So if n has some limit, then we say the sequence is convergent. Or if it is not convergent to a particular number, then we say it is divergent. Okay.
Okay, sir.
Okay. So I am giving you one small example. Let's say I have 2 sequences. Let's say an is equal to 1 by n, and the other sequence is an is equal to minus 1 power n. So let's say this is the question number 1. This is question number 2. So could anyone tell which sequence is convergent? And
1 by
which is
n
not?
is
first one.
convergent,
The first
1
one.
by n.
Very good.
and
Very good.
minus 1 to the
What
third
it
is
is-
not
what it-
convergent, divergent.
Very good. What it is converging to?
It is
0.
convergent
It is
to 0.
converging to?
0.
Very good. So if you know that as the value of n increases, the 1 by n becomes small, and
Smaller.
like we can say that it approaches 0. Okay. Whereas in the second sequence, you could see one times it will be plus 1, and one times it will be minus 1, depending upon whether it is n or whether it is even or odd. So this is clearly a divergent
Divergent.
sequence, whereas this is clearly a convergent sequence.
Sir, it is also bounded
Okay.
bounded function, na?
Which one?
The second one, sir. It
Yes, of
always
course.
lies in between
Yeah.
minus 1 and 1.
Very good. If it is, that is, if a particular sequence an, if it has some upper limit and there's some lower limit, that is, if it is between 2 numbers, then we can say that sequence is bounded. Okay. So
Yes, yes, sir.
we are using, that means there are some formulas for you, some 9 formulas. I think most of you are familiar with this. So we will using these formulas exclusively to solve the problems. So you could like see this. So let's say there are 2 sequences, an and bn, and an as limit a, bn as limit b. So there are 2 sequences. One is an, other one is bn. The limit of an is a, and the limit of bn is b. So the limit of an plus bn is a plus b. Is that clear for everyone?
Yes, sir.
Yes, sir.
The limit for an plus bn is a plus b. Similarly, the limit for an minus bn will be simply a minus b. If an and bn has some limits, let's say an has some limit a, as the value of n increases, and bn has some limit b as the value of n increases, then an plus bn, simply the limit value will be a plus b, and an minus bn will be simply a minus b. And c times an, let c be any real number, okay, will have the limit ca. Simply the constant will multiply with a. Is that clear?
Yes, sir.
Yes, sir.
The fourth point you could see, if same, like the logic is same, if an has some limit a, bn has some limit b, then a and bn, the product of the two sequences, will have limit a into b. Simply a multiplication of both the limits. And fifth point is very important. F of an will be f of a. Let f be any polynomial function. F of an will simply be f of a. Because an has limit a, simply f of an, you put in the place of an a, and you could find the value. And look at the sixth rule. An by bn will tend to a by b, but provided b is not equal to 0. So as the value of n increases, an by bn will tend to a by b, provided b not equal to 0. Because once b equal to 0, it is not defined, so we have to ensure that b is not 0. And look at the seventh point, it is c power n. Since an has limit a, it will be simply c power a, where c is any real number. And eighth one, log of an. So as the value of n increases, log of, that is an will tends to a, the log of an will become log of a. But you have to ensure one very important point when it comes to logarithm. So you have already studied logarithm is defined for positive numbers. So you have to ensure that an is positive, and this, whatever the value a we will be getting, that is also positive. So only for positive values, like this particular rule will be applied. And the ninth point, see the ninth point, we are having a sequence Cn, and Cn is in between a and bn. Is that clear? Hello?
Yes.
Sir, yes.
Yes, sir.
Yeah.
Yes,
If
sir.
an and bn
Converge
both
to
are converging to a, then Cn will converge to a. I think this thing, I think it is discussed in the video lecture, right? Sandwich theorem, right?
Yes,
Yes,
sir.
sir.
Sandwich theorem.
Yeah. So whenever when we are solving problems, I will discuss like if at all some formulas are, if we are going to use some formulas, I will discuss in that specific problem. So we will now move to question number 1. So everyone keep some notebook with you, try to solve them, and whatever the answers you are getting, you try to post them in the comment section, chat section. So I would be able to know how many people are getting the correct answers. So this is your first question. So I will be giving some 8 to 10 minutes time. So take your time, have a notebook with you, and try to solve on your own, and let me know if you have any doubts. Okay. Okay. Is it visible?
Yes, sir.
Hello? Yeah.
So, sir, no
Yes, sir,
joint
visible.
PD today?
Hello?
No joint PD today?
You are audible, sir.
No.
Okay.
Yeah. No joint PD today. Just you post them in the comment section. Okay. And let me know if you are facing.
Okay.
Okay. So there are 4 options. So you have to find out which of the options
Sir,
are.
this question is an activity session, I guess.
Acha. Okay. You solve
Sir,
once again.
also in solve with the session it's there.
It's the same question.
Same questions.
Acha. Is it in the last session you are talking?
No, in this in
Activity
the portal only,
7.5.
and also
Okay,
in solve
okay.
with us.
Yeah. Okay. If it is there, you try to solve, and we will
Okay.
wind up with it. Okay. Yeah. Abhishek Saha. Am I audible? Abhishek?
Yes, sir.
Yes, sir.
Abhishek, I could see in the comment section you have written all are false.
Yes, sir.
Like, have you solved? Have you solved?
Sir.
Like, what is the value you are getting for the question 1?
8.
8. Okay. And for 2?
-7/2.
Okay. For 3? For 3?
3 is correct. Sorry, sir.
Yeah.
For question 4, it's 0.
Good.
Actually, we don't have to put directly value in these equations.
See, if it is a polynomial kind of function, then you could able to directly put the value, right?
Right, sir. Right.
For example, there is no problem in putting no problem in putting the value directly in question number 3 as such.
Yeah, but in like question 1 in 4,
But yeah, but in other options 1, 2, 4, you have to check.
yes, sir, because it gives us
Yeah.
undefined
Yeah,
values.
if at all it is giving 0/0 form, I think you could be able to see everyone. I think everyone able to see the hint here, which is given here, right? If the function is of the form f by g, and g tends to 0 as x tends to a. In this case, if possible, try to cancel the factor x minus a from both f and g, and then try to evaluate the limit. So for question number 3, there is no problem in directly placing the value. Whereas for the other things, you have to be careful. Okay, I could able to see most of you have answered 1, 3. Okay. Pratap, what is the value you are getting for limit for question number 1?
-12/0, sir. I directly substituted -1 without factorizing.
You factorize, and if possible, if something is getting cancelled, you cancel and then try to find the value.
Yes, sir, I am doing it. Sir.
Yeah, Abhishek, I think now you have got.
Yes, sir. I have just missed -1 in the
Okay.
first.
Yeah. Aditya Pratap Singh. You have written only option 1 is correct. What about option 3? Sorry, what about question 3? Jitendra, have you found have you solved for each and every question? Your voice is breaking. Hello. Okay. So everyone done?
Yes, sir.
Yes, sir.
we are-
done.
Yeah.
Yes, sir.
Done, sir.
Okay. So for the question 1, so what is the limit value? See, for the
It's
question 1,
-1.
it is like this, right? Yeah.
Minus
So for
1.
the question 1, so see x square minus 6x minus 7 divided by x square plus 3x plus 2. factorize both the numerator and denominator. X plus 1 will get cancelled. So this part will get cancelled. So you are left with x minus 7 by x plus 2.
We will discuss that in detail.
See, initially when you put directly minus 1 for question 1 I am talking, you will get 0 by 0 form. So whenever that 0 by 0 form comes, we try to factorize and we try to cancel if anything is getting cancelled. So here x plus 1 will get cancelled. So we are left with this. And after this, that 0 by 0 form is not coming, right? So the value will be minus 1 minus 7 divided by minus 1 plus 2. It should be minus 8 by 1. So the answer should be minus 8. So most of you have got this answer, right?
Yes, sir.
Yes, sir.
Okay. And what about option? 1 minute. What about option 2? For option 2, if you put x equal to 0, is there any problem? Are you getting any 0 by 0 form?
No, sir. Minus
So-
11 by 2.
Yeah. So the
It is not
Minus
equal
7
to
by
8.
yeah. So the second limit will have the limit as minus 7 by 2.
Just
But-
put the value.
But it is given as minus 8, so it will be incorrect. Okay.
Yes.
See, for option for
Yes, sir.
question for question 2, the limit exists, but the limit value is not given as correct. It is given as minus 8. It should be minus 7 by 2. Okay. For option for question 3, I think no problem, right? It is a polynomial function. You directly place the value there. So if you place and you do that calculation, it will be fine. Okay.
Yes, sir.
Yes,
And fourth one again, it is 0 by 0 form. You could see here. X square minus 6x plus 9, I can write it as x minus 3 whole square by x minus 3. I cancel one factor. So I will left with the limit extends to 3 x minus 3. So just put the value of 3. So the limit should be 3 minus 3. It should be 0. But what is the value given here? It is 1. So that's why the option is not correct. Okay.
Okay, sir.
Yeah. Okay. So most of you have given the correct answer. 1 and 3 are the correct answers. Okay. So now we will move to question number 2. Okay. Question number 2. Okay. Is the slide visible to everyone?
Yes, sir. It's visible.
Yes, sir.
It's visible.
Sir, option 7 is not clearly visible.
1 second. No?
Yes. Yes, it's visible.
So one thing you can only like say that in uniform case, when you can just choose a uniform, don't go with the integration part. You can only stick with this area whenever it is uniform. In other cases, when it is not obvious to make this area like this plot this area, then we will do this limit part. Okay.
Raj, Deepak, am I audible?
Yes, sir. You're audible.
You are.
Raj Deepak.
Yes, sir.
Raj Deepak, you have written in the chart section only what you have written?
Option 7.
Only, yeah, like you have checked the other options.
Yes, sir. I have checked.
Only option 7 is right, according to you, right?
Yes, sir.
I advise you to go through the question once again. Okay. Look at the graph carefully and try to try to go through the question once again.
Okay, sir. I'm going to check again.
Yeah. Rajit Kumar, he's asking unique here means like one tangent. There exists one tangent. Vaishnavi Verma, 1-5 are correct, or else are wrong. Vaishnavi, please go through the graph once again and properly check what will be the limit value of this function when it is tending to 0.
Explain this part and then I will
I think like here 0 is missing, right? Like everyone got this. This should be 0. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
It
sir.
is under.
It's understand.
Yeah.
So if
And
it's
could
0, then the function
hello?
is also tending to 0, right?
Yeah. Like someone Vaishnavi Verma, like she wrote 1-5 are correct. So I'm saying her to check once again. Okay. Could anyone tell like which function has this kind of graph?
Sinusoid.
Very good.
Sin x.
Sin x.
Sine.
Is it correct, sir? Sin x.
Yeah. It's correct. Preet Patel, monotonically. Monotonically means like in the same way. That means monotonically increasing or monotonically decreasing. That means it basically means it should preserve its order. If it is increasing, it should keep on increasing. It should not decrease and then increase. Such things should not happen. Okay, Vaishnavi. Okay. Pratap, you have written that option 3 is correct. Option 3 says limit of the function as x tends to 0 is undefined.
No, sir. It was a mistake. It should be 2, sir. Option 2.
Yeah.
step function in discrete case. In discrete case, it will be step function.
Hello, sir.
Hello.
Sir, for sine graph, it should be down to the x line also, na? But it is upper to x-axis.
Acha.
Are you getting what I'm saying?
Yeah.
That's why I said that option 1 is not correct.
Okay, 1 minute. Graph of the.
Sir, this is not a sine graph.
Yeah. This is not a sine graph. I think it should be 1 minute.
Exactly.
Okay, let us
Sinusoidal
not
graph.
like see. Actually, yeah. Actually, if it is something like this, then we can claim it's a sine graph, right?
Yes,
Yeah,
sir,
this
right.
is passing through the origin.
Yeah, yeah.
Yes.
So let us not get into that. Okay, we will from the graph we will try to analyze it. Okay.
Okay, sir. Sir, and where you retain 0, is that something dark line? Is that matter here for solving this question?
Which one? This part.
Uh, upper
See,
side.
like
Yeah.
see, this is 0. This is like on the right side there are positive values, right? 0.5, pi, 1 pi. Okay. Is that clear?
Okay, sir.
On the left side there are negative values. So 0 is missing. So I just mentioned that it should be 0. Yeah, it should be like sinusoidal. Okay. Okay.
So meanwhile, I had a certain query. May I?
Yeah.
So actually, just wanted to ask, like,
Hello?
are we done with? Am I audible?
Yeah, you are
Hello?
audible.
So I just wanted to
Hello?
ask, like, I'm asking, yeah. So are we done with the topic that the function converges and diverges?
Converges and diverges. No, not yet.
Yeah, we'll do that now, Abhi.
Yeah, like I have 5 questions. See, I will like I have 5 questions. We will do those 5 questions, and after that, you have any doubts, I will take that. Okay.
Okay, so thank you.
Yeah. Okay. Shall we see the answers? We will do one thing. We will
Yes,
analyze option.
sir.
We will analyze option by option. Okay. So option 1
Okay.
says limit of the function as x tends to 0. So x tends to 0 means you have to approach 0 both from right hand side and left hand side, right? So either you approach from right hand side or you approach from left hand side. The limit value is tending to 0, right?
Yes, sir.
So option 1 should be
Yes.
correct. So limit of the function as x tends to 0. Okay, sorry. Option 2 should be correct. Limit of the function as x tends to 0 is 0. Is that clear?
Yes, sir.
Got it,
But
sir.
Yes, sir.
option 1 is saying limit of the function as x tends to 0 is 1. It should not be 1. It should be 0. Is that clear to everyone?
Yes, sir.
Yes,
Clear, sir.
yes, sir.
Yes, sir.
Okay. So option 2 is correct. So option 1 is incorrect, and similarly option 3 is also incorrect. Okay. Next, option 4. There is unique tangent at the point x equal to pi, but not at x equal to minus pi. So where is x equal to pi? This point, right?
Yes, sir.
Hello?
Yes,
Yes, sir.
sir.
Where is x equal to minus pi? This is this point, right?
Yeah.
Yes, sir.
Is there a sharp turn at those points?
No.
No,
No,
sir.
No,
sir.
sir.
No.
There is a curve.
So, yeah. So obviously there will be unique tangent. So option 4, it is saying there is unique tangent at x equal to pi, but not at x equal to minus pi. It should be incorrect.
Incorrect.
Is that clear?
Yeah.
But
Yes, sir.
Yes, sir.
option
Yes,
5
sir.
is correct. It is clearly saying that there is unique tangent x equal to pi and as well as at x equal to minus pi.
Yes.
But it is not unique, no, sir. If we extend the tangent, both of them will touch together again.
Yes, sir. Y is equal to 0.
See,
Then
like,
how it is
see,
unique?
see, the thing is at x equal to minus pi, there is one unique tangent, right? There is only one tangent, right? At x equal
Yes,
to
sir,
minus pi.
because
Yes, sir.
only one
And for-
tangent can be
Yeah,
drawn.
Sir.
similarly, you check at x equal to pi.
Okay.
Okay, so
Both the
at both
values
points,
on.
yeah.
Sir, in today's office hour sessions,
Yeah.
I asked this doubt, and sir said that these are not unique because
not
y is equal
unique,
to
no,
0
sir.
both sides.
So
What are you saying?
if it is not unique, then maybe it will be right, sir. But it is specifically given there is a unique tangent because they are saying it. But the line will almost be same, no, sir. It
Like,
is like an
see,
exact.
that means see, like see, first we take this point, let's say x equal to pi. I have to just see if that means is at this point x equal to pi. I just have to check whether there is one tangent or not, right? It is having one tangent.
Okay.
I think you are like many of you might be confusing with this word unique, but it should be like we have to check at the both points whether at this point if there is one tangent, okay. Whether at this point there is one tangent, okay. So that's how we have to look at this
Check.
option.
So
Right.
can we explain this with equation of the both tangents?
Both equation of both the tangents.
Yes, sir.
See, like the thing is, see, the tangent which is that means for at x equal to pi, whatever be the tangent, that is also the tangent at x equal to minus pi. That's what you are saying, right?
Yes, sir.
Yeah, but what I'm saying is, but at x equal to pi, there is only one tangent, right? One unique tangent, right? And
Okay.
at x equal to minus pi, there is also one tangent, right? That's how we have to see this option. Is that clear?
But if you increase to the right side this tangent, then this will be the same line. Then how it will be tangent unique? You can increase to the right direction.
The
no?
thing is like you understand like this. We are talking uniqueness at that one particular point.
So the tangent definition itself says it in the very small neighborhood. We have to check the tangent. So maybe what you are saying is right.
See, what I'm saying is at x equal to pi, there is like only one tangent, right? Because there are no sharp turns. Okay, that is clear. And similarly, at x equal to pi, there is also one tangent because there is no sharp turns. They are not saying that like that means like both the tangents are the same, but at one point there is unique, right? At one point, that means at x equal to pi, there is only one tangent. So that's how this option is correct. Okay. Hello?
Okay, sir.
Yes, sir.
Yes, sir. Yeah. Yes, I got it.
Sir, I think
Okay,
if you can
and-
draw at that point, then they can understand better, like pictorial representation with your stylus at that particular point,
Yeah.
how tangent would be there, then they can understand better. Just
Yes,
opinion.
please.
See, 1 minute. 1 minute. Is my board visible?
Yes, sir.
Yes, sir. It's
Yes,
visible.
Yes, sir.
Yeah. Let's say we are having this curve, right? Okay.
Okay.
Right.
Now tell me at this point, how many tangents are possible?
One.
Only one.
One tangent.
Only one.
Unique, right?
Yeah.
unique.
Yes.
Unique to this point, right? Is
Yes,
that
sir.
clear?
Yes.
Yes,
Okay.
sir.
Now at this point,
Yes, sir.
at this point also we are having one tangent, right?
Yes.
Yeah.
Yes, sir.
Let's say the curve like this. Okay. Let me draw another curve. See, in this question, like if you take this point, okay, we just have to check whether there is a unit tangent at this point or not. If you take this point, let's say this point is some x1, this point is some x2. At x1, let me check if there is unit tangent or not. So at x1 there is unit tangent, right?
Yes,
And in
sir.
the same way at x2 also there is unit tangents.
Yes, sir.
So now everyone able to understand what the question is basically asking. We just have to
Yes, sir.
confirm
Yes,
whether there is a
sir.
unit tangent at this point. So
Just a second, sir. Instead of x2, there will be x1. I mean, both will be equal. Then it will be still unique.
see, let's say here there is some tangent, right? It will have some equation, and this tangent will also have the same equation. We are not talking about the same equation or the same line. We are saying we are just confirming whether at this point there is a single tangent or not. That is, there is a unit tangent or not, and also we are confirming whether at this point there is a single tangent or not. That's what the basic that is the option is like asking.
Okay, this is about indivisible.
Yeah, at that particular point. Okay, not the
Okay, sir.
combined one.
Actually, in office hours, sir confused me.
Okay.
Now I get it, sir. Thank you.
So let me see the options. So I think most of you have gave the right answer. It should be 2 and 5. Okay.
Yes.
Okay. So let me look at the options 6 and 7. So in the interval minus 0.5 pi and 0.5 pi. So this is the interval, right? So let me highlight that for you. So this is the interval. So could anyone tell what is happening in this interval?
It is decreasing,
Minus
sir.
0.5 from decreasing from where to where?
Mi-
is
minus
decreasing
minus
from
0.
5 to 0.
Minus
Very good.
0.5
Very good.
to 0.
Very good. And what's happening from 0 to 0.5?
Increasing.
Increasing.
Increasing, sir.
But in the option, it is saying the given function is monotonically increasing. That's
The-
not the case, right?
Yeah.
So let me do one thing. Could anyone tell? Let me. So what's happening to this function?
Increasing,
Monotonically increasing.
sir.
Y equal to
Strictly
x,
increasing.
strictly increasing.
Very good. This one?
Monotonically
Decreasing.
decreasing.
Monotonically, monotonically decreasing.
What happening to this?
This is increasing
Neither
with the way.
increasing. Combination of both decreasing.
Very good.
This
Very
is
good.
only
Very-
increasing
bounded
and
kind of.
then decreasing.
Okay. Bonded. Okay. So if I take this particular interval, let's say this is my x1, this is my x2. What's happening in this interval x1, x2?
Monotonically decreasing.
Decreasing,
it is
sir.
decreasing.
Yeah.
Very good. Now let me take this point over here. Let me take this as x3, this as some x4. What's happening in this interval? x3 to
Increasing.
x4.
sir.
It's
Increasing,
Increasing, sir.
increasing.
It's increasing.
So like see when you're having this kind of functions, if so see here in the question, what is the interval? The interval is minus 0.55 to 0.55. So in that you could see there is both the decrease and increase. So we cannot claim that it is monotonically increased. Okay. So if you are able to restrict some interval, or if I talk, see if I consider this interval, let's say from 0 to 0.5. If I take this interval 0 to 0.5, then
It is increasing, sir.
very good. It is increasing in this interval.
It is increasing monotonic.
Very good. And if I take this interval minus 0.55 to 0,
Decreasing.
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 but we are but when we are combining this both, can we claim that it is monotonically increasing? That should not be the
No.
case.
No, sir.
Oh, no.
That's why
sir.
option
Sir.
6, option 7 are correct. Okay. Okay. So shall we move to the next question?
Yes, sir.
Yeah,
Yes, sir.
sure.
Okay, sir.
Hello.
Sir, if it not monotonically, what we call it is?
Which one?
It is increasing and decreasing both. It from
Yeah,
zero
we can
minus
say that
0.5
it is yeah, you could simply say that in this interval it is decreasing and in this interval it is increasing. Okay, both increasing and
But-
decreasing.
Okay, sir. There is any term like monotonically, it is bitonically, like anything?
No, nothing as far as I know. Okay,
Okay, sir.
you just say it is increasing this particular interval and decreasing this particular interval. Okay. So let us move to the question number 3. So there are so many options. So whosoever is posting these options in the comment section, you try to post them in the ascending order. Okay. So are these 3 formulas known to everyone? Limit x tends to 0, sin x by x equal to 1.
Yes, sir.
Yes, sir.
Limit x tends to 0, log 1 plus x by x equal to 1. And limit x tends to 0, e power x minus 1 by x equal to 1. Try to solve each and every question in your notebook and like you post the answers in the comment section.
What was your question again? Can you ask again? Because this PDF, that what so the probability PDF is not exactly the probability. Probability is the area under the PDF. So now we are since we are going to find the probability, then we need to find the area under the like the limits that are given. That's why we need to find the PDF. And when you integrate PDF, you will find area. So that's why we integrate.
Sir, I hope all the students has finished this question. Can you explain, please?
Yes, sir.
Hello. Is everyone done?
Yeah, sir.
Yes, sir.
Yes, sir.
Yes, sir. Done.
Yes, sir.
done.
So the correct options are 1, 4, 8. Okay. I will do one thing. I will try to solve some of this. Okay. Because I could see many of you are getting 3, 8. Pratap, you have solved all the 9 options. 1, 3, 4, 6. Okay. Okay. I will do one thing. I will tell
No,
the
sir, I
approach.
couldn't solve.
Then you. Yeah. Okay. 1 minute. Okay. So is my board visible?
Yes.
Yes, sir.
Yeah, it's visual.
Yes, sir.
Okay. So everyone know this formula, right? Limit x tends to 0. Sin x by x equal to 1.
Yes,
Right?
sir.
This is familiar for everyone, right?
Yes, sir.
Yes, sir.
Okay, this is familiar. Now, let me find what will be the limit of this one. Limit x tends to 0. Sin ax by x. Is that clear?
Yes, sir.
Yes, sir.
This one I know. This one I know. Limit x tends to 0, sin x by x equal to 1. But I have to find limit x tends to 0, sin ax by x. So what I'm doing is, I will just tell what the procedure is. See, what I'm doing is, let me take ax as some y. Okay. Let me take ax as some y. Now tell me, if x tends to 0, ax will also tend to 0, right? Hello? If x
Yes,
tends to
sir.
0,
Yes, sir.
ax
Yeah.
will
Yes,
also,
sir.
that is y tends to 0. So this can be written as, this limit can be written as limit. In place of x tends to 0, I will write as y tends to 0. In place of ax, I write as y, because I have taken ax equal to y. And what should I write in place of x? Hello?
Y,
Should I
sir.
write in place? What should I write in place of x?
Ax.
Y by A, sir.
Y by A.
Y.
Very
Y
good.
by.
From
Y by
this, x will be y by a. So let me put here y by a. So this entire limit turns out to be a into limit y tends to 0, sin y by y, right?
Yes, sir.
Yes.
Is that clear? So
Clear.
now this both these are same, right? This one and this one. The variable doesn't matter. Both these are same, right?
Yes,
Hello?
sir.
Yes,
So what
sir.
will be the value of this limit?
sir.
It will be a.
A.
Is that clear?
Clear, sir.
Right.
Yes, sir.
Yeah. So remember this formula. Two formulas. One is, you know this one, right? Limit x tends to 0, x by x equal to 1. But what is the value of this one? Limit x tends to 0, sin ax by a, ax by x. So what will be the limit value of this one? It will be a.
Yeah.
Is that clear for everyone? Yeah.
Yes.
Yes, sir.
Not,
Yes, sir.
yeah, whatever the value that is. Now with this logic, we try to see the option. So now tell me, for option 3, what will be the limit value?
That's gonna be
Hello.
3, sir.
So this formula is clear, right? I'm adding one more additional formula here. That is limit x tends to 0, sin ax by x should be a, right? Okay. So
Yeah.
for option 3, what is the value of a?
3.
3, sir.
For option 3,
It's
yeah. So
3,
here
sir.
it should be 3, right? Here it
Yeah.
should be 3, but here it is given as 1. So option 3 is incorrect.
Incorrect.
But option 4 is correct, right?
Yes, sir.
Yeah.
Yes,
Both
sir.
are right.
Now, could anyone tell what will be the limit value for option 5?
5.
5. What is
Yes.
because a
1 by
a,
5.
yeah, 1 by 5. So it is also incorrect, right?
Yeah.
Yes, yes, sir.
So I think for options 3, 4, and 5, the approach is clear, right?
Yes, sir.
Yes, sir.
So we make use of this particular formula, which is sin ax by x is equal to a. Okay?
Yeah.
Yes, sir. No
Yeah.
problem.
Yeah. Now let me get into the other things. Okay. 1 minute. So what will be the value of this limit? Limit extends to 0. E power x minus 1 by x. What will be the value for this?
1.
1. 1.
1. Now tell me what will be the value for this limit? Limit extends to 0. E power x minus 1 by x.
A.
Hello?
Yes, sir.
Yeah, it should be A, right? I
Yeah.
could proceed in the same way. I can take ax as y. I could proceed in the same way, and I could show this limit will indeed be A. Is that clear?
Yes, sir.
Yes, sir.
See,
Yes,
what we are doing is, if it is Ax here, we are ensuring that there is also Ax here. For that, I have to multiply A here and A here. So this particular limit will be 1. So A times 1, it should be A. Is that clear?
Clear,
Yeah.
sir.
Yes. Yes, sir.
Yeah. In the same way, what is the value of that limit? The other limit, what is the formula? Limit extends to 0. Log 1 plus x by x, right? What is the third?
sir.
Okay.
One,
Yeah.
one.
Yeah. It is log 1 plus x by x. Okay. Okay. Now tell me, what will the value of this limit? Limit extends to 0. Log 1 plus ax by x. A be any number, okay? Other than, yeah, it should be A. Is that clear?
Okay. Yes, sir.
Yes, sir.
Clear.
Yes, sir.
Yeah.
Yes.
Now let me do one more thing. Now let me say, let us take this limit extends to 0. Let me take 1 minute. Okay. Limit extends to 0. E power ax minus 1 by sin bx. Is this clear for everyone? I have
Yes,
to find
sir.
the limit value of e power
Yes.
x minus 1 by sin bx.
A by
Now
B.
what I am doing is 1 minute. So let me rewrite this limit. So I divide and multiply. That means I divide by x both the numerator and denominator. So it will be limit of e power ax minus 1 by x by sin bx by x. Is that clear for everyone?
Yes, sir.
Yes, sir.
Now we can split this limit both for numerator and denominator. It will be limit extends to 0.
It's
E power
by
ax minus. Similarly, limit extends to 0. Sin bx
Sin
by
bx
x.
by bx.
Okay. So these formulas are already known to you, right? I just gave the formula for what will be the value of for the limit which is in the numerator. It will be simply A, right? Because the value is here A, right? And what will be the value for denominator limit?
B, sir.
B.
B,
Yeah.
because it is B here, right?
Yes, sir.
Is that clear?
Clear, sir.
Clear. Clear.
So now I think yeah. So now I think you could be able to solve each and every option. So let me check. First one,
Sir?
you simply divide the, hello?
excuse me,
Hello?
sir.
Yeah, you can ask.
Sir, we can't say that sin bx by bx is equal to 1. We can say that. But we can't say that bx by sin bx. It's incorrect.
Let me write what you are saying. See, the value of this limit, sin bx by x, this is B, right? Is that clear for you?
Yeah, sir.
Now, what you are saying? Limit
Sir?
extends to 0, sin?
No, no
Hello?
sin.
What you are saying?
Sir, not sin. Only bx by sin bx.
Okay, so it's the other way, right? Bx by,
Sin bx.
okay. Can I rewrite like this? This one?
Yeah.
Can I rewrite like this?
Yes, sir.
Now, what will the value of this limit?
1 by B.
B.
One.
1, sir. 1.
This will be
Only
1,
one.
right? Because
One.
here,
One.
here
Yes,
it is
sir.
bx, here it is. So it
Yeah.
will be 1. Is that clear?
Yes, sir.
Yes.
Yes, sir.
Thank you,
Yes.
sir.
So 1 minute. So option 1 is correct. And option 2, sorry,
Okay, we
option
can
1,
say-
option 4, and option 8. Okay.
Sir?
Hello.
Sir.
Yes, sir.
Hello. Someone is asking something. Hello. Am I audible?
Yes,
The
sir. So with this
values are different, sir. The options you have shown and now what you are showing values are different. For
Is it
option
so?
4.
So can we
Oh,
say that
sure.
x upon sin x is also going to be 1?
Yeah. X upon sin x limit extends to 0 is also 1.
And is this
I
similar?
I just shown you, right, that one. This particular.
So similarly, it will be e to the power x minus 1 upon x. If it's turned around, then it will be 1 as well.
Yeah.
And the log
Yeah.
as well.
You can write like this. Yeah.
Okay.
You can rewrite like this and you can show. Okay. No problem. Pratap, you're saying something?
So could you simplify the first option, sir? Log 1 plus x by sin x. How we got 2?
Okay. See, there is a 2 here, right? That's why the 2 came. Could you able to see this? There is a 2 over here, right? This limit will be 1. 2 into 1. That's why the value is 2.
Right. Okay.
See that.
Sir, discuss
but-
option
so the
2,
option.
sir.
1 minute. The option 1 is like this, right? Limit extends to 0. There is a 2 over here. This limit will be 1. You can divide the numerator and denominator by x and you shift the limit and like the way we did in this problem. Okay. So this will be 2 into 1. This will be 2.
Okay, sir. Right.
Hello. Someone is asking something.
Yes, sir. Discuss option 2, sir.
Option 2. Option 2. I have
Because
discussed.
there is
like, this
nothing is
option 2.
unequal to. How we compare this? And
Which
how we
one?
say option 2, sir.
Option 2. Acha. See in option 1 and option 2 are same, right? So what is the value for this limit? It is 2, right? But option 2 it is saying it is undefined, right? Which is not the case.
Sir, but is unequal to, it can be anything else. There is nothing mentioned in equal to. So how we can say directly it's undefined?
Nahi,
In
there
option
are-
1, there is saying equal to 2.
They are
Then it's
asking whether this limit is undefined or not. See, we calculated this limit. Is it infinity?
No, it's 2.
It's 2, right? So then the statement is incorrect, right? It is saying it is undefined, but it has a
Okay.
proper value which is 2. Okay.
Yes, okay.
Option 8. How many of you got option 8 as correct?
Yes, sir.
Yes, sir. Me also.
So like
Option number 8.
okay, shall I do option 8 for anyone? If you're having anyone having any doubt?
No doubt, sir.
No doubt, sir.
1 minute. Someone has raised their hand. Okay. So remember these formulas, okay? These 3 formulas: limit extends to 0, x by x is 1. Limit extends to 0, log 1 plus x by x equal to 1. Limit extends to 0, e for x minus 1 by x equal to 1. And also the corresponding formulas, that ax1. If you remember this, you could be able to solve all these formulas. Okay?
Sir,
Hello?
sir, in log formula, limit extends to 0, log 1 plus a into x by x is tends to a, sir.
Yeah.
Sir,
Shall I
once
show that
tell-
formula once
once
again?
explain that.
This one, right?
Yes, sir. Sir, how it is possible? Log 1 plus x by x is equals to 1, sir. But how 1 plus log of 1 plus ax by
See.
x is equals to a?
Yeah, see, like you understood this part? The derivation for this one, where I took ax as y. Okay. Then
Yeah, I
I
understood.
showed that, yeah, in the same way, for this case also, you take ax as y and you could able to show that this limit is indeed a.
Okay, sir.
Okay, you take ax as y and proceed in the same way, you could able to show that.
Okay, sir.
Shall we move to the next question?
Yes, sir.
Okay, so next question is a little bit complicated. So take your time and try to do that, okay? Okay. So is it visible for everyone?
Yes, sir.
Yeah, it's
So
Yes, sir, it's
you are supposed to find this limit value, and for solving this limit value, you could use these formulas which are there. So these are some standard limits which are given to you, and make use of this formula to find the value of this limit. I think this is visible, right? This is E. This is also E.
Yes, sir, visible.
Yeah, here, carefully observe, there are factorials. Okay, this is x factorial. Okay, root x factorial, this one. Ayush, have you done? Alok?
Yes, sir, I've done it.
Hello?
Yeah, I've done it. It is coming out to be 6 minus 1, 5.
Yeah. 5 is the answer.
Yeah, same for me.
Who else completed? Aryan, Purnisha. How many steps you guys are getting? How many steps?
Please, everybody mute.
Those who have done speaking, please mute yourself. Indal, what is the answer you are getting?
Sir, 7.
7. Okay. You do one thing, you go through the steps once again. Some mistake might have happened. One thing, let me tell for everyone, like in this particular problem, we have to use one important fact, that is, as n tends to infinity, 1 by n tends to 0. Yeah, make use of this fact. It is required in this particular problem. To solve this problem, these 4 things we have to use. Log 1 plus x by x1, e power x minus 1 by x equal to 1. And this limit extends to x into root of 2 pi x by x factorial whole power 1 by x equal to e. And the other one, x by root of nth x root of x factorial is equal to e.
Any hints, sir, how to start the simplification? From where to begin? Couldn't start.
Yes, sir. Please.
See, we have to make use of these things. We have to make use of these 4 limits and try to find the value. Wait 1 minute, I will be solving this, okay? Because most of you will be having doubt in this. Okay, have everyone copied this question in your notebook?
Yes, sir.
Yes, sir.
Yeah. So, I will solve, okay? Then we will look. Okay. So, shall I solve?
Yes, sir.
Hello?
Please.
Yeah.
Yes, sir.
Okay. My board is visible?
Yes, sir.
Yeah, it's visible.
Yes, sir.
So the question is limit. 1 minute. Okay, the question is limit n tends to infinity e power. What is it? I think
10th root of 10 factorial.
Sorry, it is not e power. It is e into, right?
E into, sir.
E into nth root of n factorial. and inside the bracket it is log.
Log 1 plus 6 by n.
Okay, 1 plus 6 by n
Minus
minus
e to power 1 by n.
minus 1
divided by
upon
under root 2n pi.
Okay.
Whole power 1 by n.
Pratap?
In the numerator also it is e to the power 1 by n minus 1, sir, not in the exponent.
Which one?
Yes, sir, not in exponent. E to power 1 by n, not minus 1. It is in
the numerator it should be minus 1, sir, not in the exponential of e.
Okay,
That's
sorry. 1. 1. Okay, so
Yes, sir.
is it okay?
Right, sir. Right.
Yeah. Okay. Now, so let me simplify this. Limit extends to infinity, e into nth root of n factorial. Now see, I want to use this fact. Already I know this fact, right? Log 1 plus x by x, right? As x tends to 0, okay, will be 1, right? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
So in order to use this particular formula here, so what I should do is 1 plus, this is log 1 plus 6 by n. I think I should divide by 6 by n, right? Is that clear?
Yes, sir.
Yes, sir.
yeah.
To make this particular limit look like this, okay? But if I divide by 6, that is if I divide by 6 by n, so I'm like, there will be extra term in the denominator. So to compensate for that, okay, I have to multiply 6 by n over here, right? Is that clear for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So this highlighted one minute, let me highlight this. This highlighted one, this yellow part, will be same like this. Is that clear?
Yes, sir.
Yes, sir.
Yeah. Now the other thing, here it is e power 1 by n, right? So I have another formula, right? The other formula is limit extends to 0. E power x minus 1 by x equal to 1, right? So I will make use of this fact here. So it will be e power 1 by n minus 1, right? I will divide by 1 by n, and to compensate for that, I will multiply 1 by n. Is that clear for everyone?
Yes, sir.
Yes, sir.
Yeah. And this term will remain same, which is root 2 pi n whole power 1. Is that okay? Hello?
Yes, sir.
Yes,
Yes, sir.
Yeah. So the green parts, whatever are there, right? These are same, right? See,
Yes,
in order
sir.
to make use of this formula, okay, in order to make use of this formula, I have written, that means I have rearranged the terms over here to make use of this formula. Step 2 is clear, Pratap?
Yes, sir. Yes, sir.
Yeah.
But here the x is tends to infinity, right?
Yeah. We will look into that.
Okay.
Yeah. So till this part it is clear, right? See, I already told you we are going to use one important fact, which is as n tends to infinity, 1 by n will tend to 0, right? N tends to infinity, 1 by n tends to 0. So no problem in that because it is 6 by n, and it is 1 by n. So like this limit will be exactly like this, because if n tends to infinity, of course 1 by n will tend to 0. So the limits are the same, right?
Got it. Yeah.
Yeah. So till this part it is clear. Now what I'm doing is, like you could see this term over here, right, which is nth root of n factorial, right? Hello?
Yeah.
Yes,
Yeah.
sir.
So I am moving this particular term into the bracket. So now look carefully. This limit will be limit n tends to infinity. E is a fixed number. Let me let it be like this. So this will be log 1 plus 6 by n, okay, by 6 by n, okay. So here it will be 6 by n into nth root of n factor. Is that clear?
Sir.
Hello?
Sir,
Yeah,
excuse me,
Yes,
sir.
sir. Yes, sir. It's okay.
I have one doubt, sir. Sir, if E is a constant, right? So can we take E outside of the limit? Because
Yeah, it is outside.
we
It is
will-
out. Yeah, you can either shift the limit, this E value even here also.
Yes.
Okay.
Okay.
Okay, no problem. Okay. So the other part, so it will be e power 1 by n minus 1 by 1 by n. Okay. See, since I shifted this term, which is nth root of n factorial inside, it will be multiplied with both the terms, right, in the bracket. Hello?
Right, sir.
Yes, yes, sir.
Yeah. So here also it will be nth root of n factorial by n by the other one is
Root
it?
2 pi n.
Yeah, root 2 pi n. Root 2 pi n whole power 1 by n, right?
Yes, sir.
Okay, till this point, is it clear for everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Now, there is one more formula we have to use. So two more formulas, right? So let me write that for you. The one formula we have to use is limit x tends to infinity. These formulas are already provided in the question itself. Okay, x by x root of x factorial is e. The other thing we have to make use of it is limit x tends to infinity x into root 2 pi x by x factorial whole power 1 by x. So this is also e. So we have to make use of these two formulas in our solution. Okay. So
Yes, sir.
let me highlight that 1 minute. So this formula and the other one we have to use this formula. Okay. Okay. Now, so like you people tell me what changes we have to make in order to use these formulas.
Have to use divided.
Limit
by-
n tends to infinity, e. Okay. The yellow part I won't make any change, right? I will keep it as it is. 1 plus 6 by n by 6 by n.
Sir, this yellow part can't be converted into 1.
Yeah, we will convert. We will convert the end, like we apply the
Oh.
entire limit value in the end. Okay.
Oh,
So let
okay,
me
sir.
first. Okay. Now, this part I can write like this, right? This part, that is this part. Okay. This part I'm writing like this. This is 6 by n by nth root of n factor, right? Is that clear? It is same as above, right?
Yes, sir.
Hello? Is that clear for
Yes,
everyone?
sir.
Yes, sir.
Yeah, sir. Continue.
Yes, sir. Clear.
Minus e power 1 by n minus 1 by 1 by n. Now tell me what changes we have to make here. What changes we have to make here?
We have to bring n factorial in the denominator of the denominator.
Here, like in order to use the last formula, okay, limit x tends to infinity, this one. Let me write 1 minute. So I will do one thing. Already it is 2 pi n, right? Okay, so 2 pi n. I am multiplying n over here, right? Okay, I will adjust for that. Let me first multiply that. Is that clear? N into, I'm bringing an extra term here, n factorial, whole power 1 by n. Is that clear for everyone?
Yes, sir.
Yes, sir.
So in the numerator, it is nth root of n factorial by n. Now see, I have bought an extra n here, right?
Yes,
So
sir.
in order to compensate that, I have to divide by n. And you could see over here, I have bought an extra term, which is nth root of n factorial. So I have to, in order to compensate for that, I have to write nth root of n factorial. Is that clear? This
Yes,
extra
sir.
thing
Yes.
is for the compensation.
Yeah, sir.
Yeah. So now I think things will become simpler. Okay. So what are the cancellations we can do? These things will get cancelled, right?
Yes,
Yes, sir.
nth root of n factorial by n.
Okay. Yeah. So let me rewrite like this. This is e in place of n tends to infinity, can I write, that means if n tends to infinity, can I write 1 by n tends to 0? Let me take,
Yes, sir.
let me
Yes,
take
sir,
1
we
by
have
n
to
as some
write.
k, then it will be, then it will be limit k tends to 0 log 1 plus k by k, right? This is 6 by, right? This will remain same, limit n tends to infinity n by root over nth root of n factorial, minus, here it will be again limit k tends to 0 e power k minus 1 by k, by the denominator we have n limit n tends to infinity root of 2 pi n by n factorial whole power. Now it's a matter of substitution of all the formulas. Okay, so let me substitute one by one. So this is e times, so this is 1, right? 1 into 6 by this value is e, right?
Yes, sir.
Minus the numerator value over here, it is 1 by the denominator value is e. So it is 6 into e into 6 by e minus 1 by e, which is e into 5 by e. So the value turns out to be 5.
Sir, can you just repeat the part written in red color?
Yeah. See, in this log 1, right? Log 1 plus 6 by n by 6 by n. Okay. As n tends to infinity, 1 by n tends to 0, right?
Yes, sir.
I have taken 1 by n as some k, so I can rewrite this expression, log expression. Let me highlight that for you. This log expression, right? Like this. Okay. Is that
Yes,
clear?
sir. Yes, sir.
It will be log 1 plus k by k. K tends to 0. Okay.
Okay, sir.
This part is also comfortable, right? This one, right? N by
Yes.
this is like clear formula. Okay.
Yes,
And
sir.
here the green one, right?
Yeah,
1 by n I
it
have
is,
taken
sir.
it as k.
Yeah,
It is limit
yes.
k tends to 0. Okay.
Okay,
These
sir.
parts are cancelled and the denominator limit is simply e, right? As n tends to.
Okay, sir. Okay, understood.
Yeah. Yeah. Hello.
Sir, I have one silly query, if I may ask.
Yeah, yeah, sure.
Yes, sir. Second line, you have written limit e. The second line, yeah.
Okay.
You have written an arrow in the second line. I didn't get that part. 6 by n upon
Which one?
n factorial whole root. That part. Second line, sir.
Is it the yellow part you are talking?
Yeah, there's an arrow adjacent to yellow part in second line. You have
Second line arrow. 1 minute.
In the solution, third
Are you
line, sir.
talking of this? Acha. Like, see, this part are you talking? Hello? Hello?
Yes, sir.
Are you talking of this part? Yeah. It is something like this, right? It is, let me write like this. So if it is a by b, I can write it as 1 by b by a, right?
Those who don't have query, please mute yourself.
Yes, sir. Yes, I am getting a by b. I can write it. Yeah, 1 upon b by a.
Yeah,
Okay.
that is what I have written. Yeah, that is what I have written.
Thank you.
See, it is root of nth root of n factorial by n. You consider it as a by b. Okay, I have written as 1 by b by a. Okay, have you understood that shift?
Sure. Thank you, sir.
Yeah. Okay.
So actually, I'm not getting that
So-
part. We are using the fourth definition of limits. How we are making that in the
Fourth
denominator?
definition.
If you turn to the next page
Okay.
one.
See, 1 minute. Something like this, right? 2. Okay. Hello.
Yes, sir.
Yeah. So it is like this. See, the formula is, let me write the formula. So what is the formula? The formula is limit n tends to infinity n root of 2 pi n by n factorial whole power 1 by n s. Okay, is that clear?
Yes, sir.
So what I'm doing is just observe. So what I'm doing is, this is 2 pi n. Here there is n factorial, so I put a n factorial here. Okay.
Yes, sir.
And here there is n. I put n over here. So see, in order to compensate for that, so in order to compensate for n, I will divide for n. Is that okay?
Yes, sir.
And in order to compensate for this term, 1 minute. In order to compensate for this term, right? This term, this whole term. Okay. What I am putting here is nth root of n factorial, right?
Okay, sir. All right.
See,
That's
I
what
have bought an extra. Yeah. This is the extra term I bought, right? Nth root of n factorial. So in order to compensate that, so is this clear for everyone?
Yes, sir.
Hello. Yeah.
Yes, sir.
So these are the steps. This is the solution. Okay. So if anyone having any problem like in this particular solution or in this particular problem, you try on your own, and if at all you are not getting, please come in the office hours. Okay. Yeah.
Sir,
So
can you,
we'll have one more question. Hello.
sir, can you again see
Hello?
the?
Huh,
Yeah,
okay.
sir, this page, please.
Which one?
1 second.
The solution part.
Okay, you can take a
She's
screen.
Yeah, thank you, sir.
Yeah, you can take a screen. Yeah. Okay, so we are left with one more question. This is simple, quite simple. So you try and post your answers in the chat box. Okay. Is it visible?
Yes, sir.
Yes, sir. Not all options are visible.
No.
Now it's visible.
No. Yeah. Okay. So there is a company which runs 3 algorithms. So you could see there. Algorithm 1 is AN, algorithm B is algorithm 2 is BN, algorithm 3 is CN. Now this algorithm is depending on n. N here is data, number of data points. So n you can consider it as data points or data set. And these data points belongs to natural numbers. That is like starting from 1. So it is in the question it is saying the company is having large amounts of data in hand. So large amount of data means use this fact n tends to infinity. So the question is very simple. You have to find the 3 limits AN, BN, CN as n tends to infinity. Treat this as option 1, 2, 3, 4, 5. So whatever the correct options you are getting, you just comment in the chat box.
Sir, the limit n tends to infinity. It is what they saying.
Yeah, you have to find the limits of AN, BN, CN as
Okay.
n tends to infinity.
Okay, sir.
Why n? We are considering n tends to infinity. It is already given in the question because the data is growing, that the n value is increasing. We are approximating that it tends to infinity.
And when 1 by n tends to infinity, 1 by n is equal to 0, right, sir?
N tends to infinity, so 1 by n will tend to 0.
Yes, sir.
As n tends to infinity, you can use this fact 1 by n tends to 0.
Yes, sir.
Okay. Yeah. So 145 Ayush, it's okay. Someone is asking Kari Singh, will the YouTube link for the video be provided? I think this particular video is live stream. You could watch in the live video section. It should be there. Preet Patel, you're saying option 4 is correct. You try to check all the options 1 to 5.
Yes, sir. Yes, sir.
It is basically multiple select question. Yeah, more than one options are correct.
Sir, in algorithm BN,
Maria,
1 by
2.
8. Hello. In
Hmm.
algorithm BN, 1 by 8 plus minus 1 by n is in multiplying, right, sir? Minus
one whole power n. You treat it like this: minus 1 whole power n divided by n. Simple.
Okay.
Once you got the errors, you try to compare and find which algorithm is giving the maximum error and which is giving the minimum error. Sharmila, I will explain once like everyone solves, then I will explain. 1, 4, 5, most of you are getting 1, 4, 5, which are the correct options. So in order to find limit of a n, what should we do?
So we can take n square common.
Yeah, you can divide both the numerator and divide by n square, right?
Yes, sir.
So once you divide the numerator and denominator by n square, it will look like this, right? 1 plus 5 by n by 6 plus 1 by n square, right?
Yes, sir.
Now, as n tends to infinity, 1 by n also tends to 0, 1 by n square also tends to 0. So the value will be 1 by 6. What is 1 by 6 approximately?
0.166.
Yeah, 0.166. Bn is very straightforward. As n tends to infinity, minus 1 whole power n by n will become 0, right?
Yes, sir.
Because the
It gives 1 by 8.
Yeah, because the denominator part is growing.
Also
The
see an
overall
unstable.
value. Yeah, this one will be 1 by 8. 1 by 8, it is, I think,
0.125.
For C, we have to
0.1
do one thing. Hello?
Yes, sir.
Yes, sir.
For algorithm B, it is 0.125, okay?
Yes, sir.
Now for algorithm 3, you do one thing, you divide both the numerator and denominator by e power n.
Yes, sir.
Then
I
1 by
think,
7, na, sir?
No, not 1. Achha,
Why?
we're
Because
talking of the value.
how
Value
it
is 1 by 7. Value is
Value is 1 by 7.
Value is 1 by.
Sir, can you solve the algorithm 3? It is difficult.
Yeah,
Little
yeah,
bit
sure,
difficult.
sure. Is everyone done?
Yes,
Yes,
sir,
sir.
done.
Yes, sir.
Yes, sir.
Yes, sir. Done.
Okay, so 1 minute. Okay, so tell the algorithm 3. What is it? Cn, right?
En, sir.
E
Ha,
for n.
Cn. Plus 4 divided by 7
Then
En.
e to the power n.
Okay. Now what happens is as n tends to infinity, okay, this part will be infinity by infinity, right?
Yes, sir.
Yes, sir.
Numerator also infinity will tend to infinity, denominator also will tend. So we have to make some adjustment. So what the adjustment we are making is limit n tends to infinity e power n plus 4 by 7 e power. You do one thing, you multiply both the denominator and numerator by e power minus n. Either you multiply both the denominator and numerator by e power minus n, or you divide both the numerator and divide by e power n. Both are same. So this will be 1 plus 4 e power minus n by 7. Is that clear for everyone?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. Now we are making use of this fact, that is, see, as n tends to infinity, remember this, e power n will tend to infinity, right?
Yes,
Yeah.
sir.
Now what happens to e power minus n? As n tends to
Minus infinity. Minus
Zero.
in.
E power minus n is simply
Zero.
1 by e power n, right?
Zero.
It will tend to 0.
Yes.
Right?
0.
Zero.
Yeah. So this is limit n tends to infinity 1 plus 4 by e power n by 7. So this will be 1 plus 4 by e power n will become 0. Is that clear?
Yeah, 1 by 7.
Yes, sir.
Yeah. So this will be 1 by 7. Okay.
Okay, sir. Yes, sir.
Because
Understood.
e power minus n is 1 by e power n, right? Again, the denominator is growing, so obviously it will tend to 0.
Okay, sir.
Sir, actually, I tried a different way and I got a different answer. If you just hear it once.
Like you tell the procedure.
Yes, sir. The thing
How you
is,
did
I
it?
used the formula of e to the power n plus 1 upon n is equals to 1. So what I did here was
See,
the original
one minute,
I divided by 4
1 minute.
both the sides. Okay, sir, got
1
it.
minute. See, that's a 1 minute. Let me tell you. I think you have used this formula, right?
Sir, I got it because then we need to divide e to the power n upon 4 also. Then it will become complicated. Yeah.
No, I'm asking, have you used this formula?
Yes,
Yeah,
sir.
yeah,
Use
sir.
this formula here.
This formula is nowhere applicable here, right?
Because they keep on.
Because I don't have a I think it is not applicable here, right?
Yes, sir. Because when I'm dividing up the numerator by 4 also, then I need to divide e to the power n by 4 also. That will make it complicated. Now,
Yeah. Simple thing, like this is like you simply divide or you simply multiply both the numerator and denominator by e power minus 1. Sorry, e power minus n. Then the it's like you just have to use this fact that as n tends to infinity, e power minus n will tend to 0. Okay.
yes, sir.
Yeah. Okay. So what are the options? So the estimation from algorithm 1. Okay, are you able to see this? Okay, the estimation from algorithm 1, it should be 1 by 6. The estimation from algorithm 2 is 1 by 8, which is 0.125. And the estimation from algorithm 3, it is 1 by 7, 0.4. So 0.142. So which algorithm is giving the maximum error?
First.
Hello?
Algorithm first one.
Yeah, first one.
Algorithm 1. Which is giving the minimum error?
Second.
Algorithm 2.
Yeah.
Second.
Algorithm. Okay.
So in the first algorithm, but we can directly substitute when 5 by n is there, we are substituting 0 there, sir. In the after the simplification, dividing by n square.
We are making use of this fact, right? We are making use of this fact. Simply remember, as n
The voice is not audible. The voice
Sir, you
is
are
not.
not audible.
He is on mute.
Sir, our voice is not audible.
Hello, am I audible now?
Yeah, yeah.
Yes, sir.
Yes,
Now
sir.
you are.
Yes, sir.
Yeah, I have some network issue. You people do one thing. I have like given a form, like a Google form in the comment section. So you try to fill that. Okay.
Okay.
Hello.
Yes,
Yeah.
sir. Yes, sir.
Yeah.
Okay,
So
sir.
if anyone having any doubts, please join in the office hours and please check your calendar. The office hours are rescheduled. Okay. Like you check the calendar and you join in the appropriate time. Okay.
Right, sir. Yes.
Yeah.
Is sir connecting again or sir leave the session?
Abhishek. Hello.
Yes, sir.
Yeah. You guys can leave the session. Okay. Please fill that Google form. Okay. And if you're having any doubts in the activity and the practice
okay.
assignments,
Okay, sir.
please join in the live session, the office hours, and please check the calendar once that office hours has been rescheduled. Okay.
Okay, sir. Thank you,
Okay.
sir.
Thank you.
Sir, actually, I filled up that Google form, but for the office hours and for the other sessions, I'm not getting any invite in the calendar.
You have to go into the course section and add that calendar.
Achha, I have to add the calendar.
Yeah. Once you add the calendar, you will like that means the links and all will be provided.
Okay. I have to add
Go
the
to that
calendar.
course page. Go to the page, course page. Add that calendar. Then you will be able to get all those links.
Okay, I have to go to the course feed.
No, course page.
Okay, course page. Okay.
Yeah. If you have any
Thank
problem,
you.
you do one thing. You post in the Google groups, and I will tell you. Okay.
Okay.
Sure.
If any problem, what should I post, sir?
I
In
am
the
saying
Google-
if you have any problem in accessing that calendar, just post in the Google groups. Okay.
Okay, fine.
Yeah.
Thank you, sir.
Thank you, everyone. Okay.
Thank you, sir.
Thank you.
Thank you for your time, sir.
Hello, sir. I'm audible. Hello.
Hello.
Yes, sir. Sir, I got a mail. There mentions इसके बाद जो भी ऑफिस आवर्स होंगे सर उसमें करंट वीक के प्रैक्टिस असाइनमेंट के क्वेश्चन कराए जाएंगे मतलब
हाँ,
पहले
हाँ,
की तरह ये कंटिन्यू नहीं होगा क्या? जैसे पहले हम लोग किसी भी वीक के पूछ सकते थे क्वेश्चंस, लाइक अभी
नहीं
वीक
वो
7
भी
चल रहा है तो वीक 3
पूछ
पूछ सकते थे।
नहीं वो पूछ सकते हैं, लेकिन इसमें क्या है ना कि जैसा अभी
मतलब एक
like एक
सीक्वेंस वे में सर
अभी क्या होता
प्रैक्टिस
है कि
असाइनमेंट।
कई बार ऐसा होता है।
जी सर।
हाँ लाइक इसमें क्या होता है कि कई बार एक बच्चा है, डाउट पूछा है, फिर वही डाउट बहुत लोग बताने पड़ रहे हैं ना। तो अभी हम क्या कर रहे हैं, लाइक एक बार एक पर्टिकुलर एक्टिविटी को लेके करा रहे हैं ताकि सबके एक ही बार कवर हो। वैसे जनरल डाउट्स तो पूछ सकते हैं, ठीक, वैसे कोई दिक्कत नहीं।
ओके सर, वो अगर आप लोग एक्टिविटी करवाएंगे तो सर वो रिकॉर्डेड होगा?
हाँ वो मोस्ट प्रोबेबली रिकॉर्डेड होगा, वो बताएंगे, ठीक है, कल आप आ जाने एक बार बता दें।
ओके सर, थैंक यू सर।
ठीक।
Excuse me, sir. Hello.
हेलो
Sir, I have.
हेलो
Sir, I have.
हेलो व्हाट आर यू सेइंग?
Sir, I am saying I have no roll number, but what should I write the Google form? My roll number.
Simply not available, you write not available, NA.
Okay, okay, sir. Thank you.
Hello.
Hello.
Yes, sir.
Hello.
Sir, today, yes,
Atul.
sir. Sir, yeah. Sir, today only 10, 11 to 12 PM wala session
Actually,
conducted.
the office hours are rescheduled. Okay.
Okay.
For tomorrow, you do one thing. You like in calendar the timings are already given, so you join.
Okay.
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 Yeah.
Okay.
Yeah.
ओके सर, थैंक यू सर, बाय सर।
Everyone leave the